So my name's Jim Wilkins. I am the Curriculum Manager here at City of Wolverhampton College for the Engineering Department. This is our brand new Engineering and Automotive building, and it was an £8.1 million building that was funded in part by the Wolverhampton Council and also the West Midlands Combined Authority. Now, my roles and responsibilities are that I manage the department. It's my responsibility to make sure that the equipment that we have in the building allows us to deliver the course content that we want to, which obviously includes both theory work but also practical work. It's to support the students in their learning, to support the staff with any issues that they might have, and just to generally encourage our learners to strive to achieve their engineering qualifications. So we're currently stood here in the machine shop. So we have our milling and turning section in the middle. Over on the far side, we've got our advanced manufacturing section, which includes robots. We've also got our precision section, which involves CNC machines and also a laser cutter. And then we're currently stood right here in our material test section. Now the plan is to use these TecQuipment machines to show the stresses and the strains that different materials can take. The courses that we're going to be using or delivering in this building are everything from a level 1 City and Guilds qualification up to and including a HND. Okay, so we have our level 2 and our level 3 courses in between. Now these bits of equipment will be used across the board. So when we need to show and give an example of material testing, we will use these TecQuipment machines to do that. So as I've said already, we have learners right from level 1 up to our higher education courses. For our full-time learners, we have around 130 students, and on top of that we have our HE learners and then also our apprentices. So our apprentices are only in either 2 or individual days during the week. So we don't see them as often as we do our course students. But that's kind of our overall cohort. Now, per lesson, we have between 16 and 18 students per class, so that works out really nicely with the equipment that we've got. We're able to get the group around the equipment and be able to do a really good job at showing them how we test the material. Yeah, so we've found within City of Wolverhampton College that if we teach theory on its own, it isn't always as helpful to the students as if they have practical examples too. So what we'd like to do and what we have been able to achieve here now at City of Wolverhampton College is that practical tests, those practical experiments that work alongside our theory lessons. So it means that not only are the students able to look at what the theory of a test might be and how strong or which might be the strongest metal, we can actually come down here into the workshop and actually do that physical test. So that's been hugely advantageous for us during this academic year. So previously, when we were at our previous site, we didn't have any material testing equipment at all. So it was an opportunity, first of all, to see what was on the market and then to go ahead and purchase some. Now, we were looking for industry standard equipment. We were looking for a brand that could support us with our needs. So with this equipment, we will be delivering testing units right the way across our different levels of courses. So we needed something that was going to be up to the task, that was going to be able to deal with all of those stresses and strains. And through a tendering process, we came to an agreement that TecQuipment machinery was what we wanted in the workshop. So that's what we've purchased for this facility. So all the way through the process, from the initial inquiries about what sort of material test equipment was available, to the tendering process, and then also through the sales and also the commissioning and training of this equipment has been a really helpful experience for us as a college. There were a number of discussions with several members of staff from TecQuipment that were always good interactions, supportive interactions. And then David, who came out to do the training, was very knowledgeable, and he was happy to do demonstrations in front of some of our students as well. So not only was it our staff that benefited from the commissioning of the machines, it was also some of our apprentices that were here that were able to see firsthand how these machines work. So yeah, it was ideal. So thank you.
Welcome everybody. Today we are looking at TecQuipment's SM1000 Universal Testing Machine. This is a 10-ton capacity machine or 100 kilonewton capacity. We'll look at the major components of this setup. So first of all, we have our hydraulic pump. This is a method of applying the load to the ram. This is our working area here. Normally this would be behind a guard, but for today's demonstration or walkabout, we're going to leave the guard left off. So this is our area here. We have first of all our compression area here. So the kind of tests that can be conducted in there are a Brinell test, a double shear test, a cupping test. We can also look at springs. That can be a coil spring, a disc spring, or a leaf spring, as well as customers being able to do their own compression tests on concrete, etc. So that's the compression area. This area here is our tensile testing area. So by default, we supply with this machine some tensile specimens where students can stretch the specimen by applying a load via the pump, and they will be able to look at our classic Hooke's law graph of load against extension, and that will be an elastic and then a yield point and then a plastic shape graph. We have a local digital load display measuring the applied load via the ram, a digital vernier gauge, and that will measure the overall deflection, or in this case extension of the specimen, and the system is fully compatible with TecQuipment's proprietary VDAS software. This can accurately gather data, either automatically or by hand, and the students can then plot their graphs in Excel format of load against extension, etc. And it provides a very accurate and convenient way of storing data and being able to record it at a later date for analysis. So to conduct a simple tensile experiment, we would mount our specimens with these two collet arrangements there. We have a digital vernier gauge that sticks via a magnet to the top yoke, and when that yoke moves up, the readout in millimeters will provide how much deflection the yoke has travelled. The ram is powered by this hand pump, and the main advantage of a hand pump is during the elastic to plastic part of your graph, you sense feedback through your arm, and without even looking at the experiment, you know when you've reached that yield point, and you can feel the load weakening or lessening whilst it's still extending. For further tests and for greater accuracy, we can fit an extensometer, and that measures a very small and accurate deflection of the gauge length. This will introduce the students to Young's modulus, and that can be either calculated from the available data, or you can use the VDAS graph, and within the elastic region, just by calculating the gradient, this will tell the user what the Young's modulus is of this material. Now the SM1000 is also compatible with TecQuipment's DefleX system, and this is a system that allows to monitor and observe and track small movements of the specimens, in which case this is the typical specimen. We can offer this in a two-dimensional version, which uses one video camera, or a three-dimensional version, which uses two digital video cameras. So with TecQuipment's three-dimensional version of DefleX, this is particularly interesting because we can actually observe a color map of the gauge length, and we can also see slight imperfections in the material as we conduct the test. So it should be mentioned that for whatever test you are performing, whether it be tensile or compression testing, it is essential that we make use and fit the safety guard. And that is a magnetic guard that simply sits on the frame and then moved into position like so. And this must be fitted before any test is carried out. So these machines, or this particular machine, exists in the first instance because for future engineers, or in the design of automotive parts, could be half shafts, drive shafts, or even in civil engineering, it is very important to understand the material properties of the components that you're going to consider to use in the design of such applications. And this SM1000 gives a very good introduction, whether we're testing mild steel with different carbon contents, nylon, aluminium or brass.